Hello everyone! Today we are going to learn about steganography, and for that we are going to use Finsternact's challenge. This challenge is basically this image, and it hides 7 flags, and the flags look like this. Flag, I am a flag. I already downloaded the image, it's right here. And the first thing we should do is to check for visual steganography. So basically something hidden in the image itself. I can't see anything, but maybe using a tool like Steganography, this one, I'll be able to see with more detail. I can use the color table and check what are the colors that are most frequent. I already know that this is white. By looking at this, I understand that there is nothing hidden behind of or written in a color very close to white, just to be impossible to notice in plain sight. The software would give me the exact word if there were minimal changes in the colors. So if there is no visual stag, we should move to analyze this image in an X editor. Okay, and as we can see, it is a PNG file. It's confirmed. So we are looking for flags, so maybe we should look for a flag. So here it is. We have the first flag written in the headers of the file, because the data only starts here. And let's save it. Okay. First flag. Now, since we know this is a PNG file, there is something that we know. There are critical chunks. One of them is IHDR, the other is I dot, and the third one is IEND. PLT is only mandatory in some cases, and on this one it is not. Because on IHDR we have, okay, let me explain. On IHDR we have the width, the height, the bit depth, and the color type. And since this is color type 2, if you come down here, we say that it can appear for color types 2 and 6, but it must only appear on color type 3. So it would be okay if Finsternact didn't introduce this chunk. So what I do when I have a PNG is that I go directly to the IAM chunk, because after this signature you can basically have anything, files, text, and it can be in plain text or encrypted, but you can have literally anything without corrupting the file that is below it. So right here we have this. I can directly tell you that this is a zip file encoded with pkzip, and that inside we have a secret.txt. So I will create a new file and save it, stegano.zip. Let's go here and extract it. 7-zip, extract here. Okay, secret.txt, and we have the second flag. Good job. Let's delete it. Okay, now this starts to become harder. Let's delete this and let's delete this because we don't need it. Save. Now let's go back to the mandatory chunks. So IHDR, we have the width, the height, and the bit depth, and the color. Then these three bytes are always 000, so it doesn't matter. And then this is the checksum that only matters if it is wrong, because it will corrupt it. And PLTE, that is the palette of colors. It is not mandatory, so maybe we should take a look at it, because we have 7 flags to find, and I'm pretty sure that Finsternacht used it somehow. So let's take a look at this. Damn it. So let's take a look. So we have all of this. Then we have the Z text, that basically is compressed text. And right here we have the two parentheses. So maybe there is a flag here. So let's go copy this to Notepad and try to see it more clearly. Okay. $44, okay, and 30. Okay, I have an F here, and 12 divided by 4. Okay, so we have 3 bytes each. Okay, so we take 3 bytes. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And there we have it. We have the third flag. Okay, that's okay. So what are we? So let's try to look at the comments. Next we have the Z text that has an outer tag, but there is no outer, or probably it's compressed because this is a Z text. Then we have another Z text, and this is not common. Usually you only have one chunk. And you have a comment, another comment that doesn't seem to have anything, and another comment that perhaps has something here because it has more data, and another Z text with probably nothing. And then we have the I.dot, and that's when the data of the file itself, of the image, starts. So to check and decompress these text comments, mostly this one, I will use a tool called ZStag that currently I don't have on Windows because my Windows doesn't work very well with it. So I can just confirm, yeah, it's here. So ZStag Stegan, what's the name of the file? Steganography.png, and the output will give us the decoded then compressed outer is Finsternacht. The uncompressed meta comment, so this one, is the flag hiding not in plain sight. Okay, that's cool. We have the fourth flag, and then we have another flag that is LSB. So it is probably Ah, okay. So it is the bytes that were the least significant bit. I have an image here to explain. It's basically hiding the message you want in the last bit of a pixel in bits. Basically, you change the last bit to the message you wanna transfer or save. And I can give you a preview of the pixels because I have right here ImageToText done by luckcolors and cd and ImageToText, and then I'd have to type, what was it? Image to type, disable printing the pixel alpha. Yes, I want to disable. Why do I want to disable this? Because we have a color type 2, and color type 2 is each pixel is an RGB triple. So it means that it's 3 bytes. I mean, every pixel has at least 3 bytes. And if we don't exclude alpha channel, we will have a corresponding of the color type 6, and we have color type 2, so let's disable the printing of the pixel alpha. And the formats, I don't know, it's okay to be a number, and the number of pixel data, so the image width. I believe that the width is correct. Maybe I should check that. Okay, I will check if the width is correct. So IHDR, and let's change this to, let's say, B. No, damn it, not that. B, just to be safe. And yeah, it corrupts the file, so I believe it was correct. Well, it was 9 before. Okay, let's go and let's see how this goes. I need to specify. Disable. I didn't specify the image. Stereo shell. I need to. Okay, and output this to output.txt, and did it work? Maybe, let's check. Probably outputted you because I didn't specify. Yeah. Yep, it worked. So as we can see, on the first pixels we have the 0, 1, 1, 1, 1, and this is binary that converts to this flag. So this is basically the least significant bit type of encoding. By the way, since we were looking at the width of the image, maybe we should look as well at the length, because you can always hide something after. So, whoops, I don't want to change there. I want to change the X. Let's change it to 6. Maybe that's okay. Let me check. Oh, where is it? I'm lost. Okay, it's here. Okay, there's definitely more. Maybe let's change right here. Aha! So we have a new flag. a flag vertically challenged. Vertically challenged. Okay. So basically what happens is that the image that is actually loaded when you open it is the amount of the image that is specified in IHDR. So basically the loader can't load or won't load more of the image than what is specified on IHDR. So yeah, you can change this, tweak it, and show the full image. Now, I believe we have outrun all the possibilities of steganography in the chunks and others. So maybe we should move to the data itself. We already found one in the data, the least significant bit that this tag thankfully gave it to us. And by the way, this could be the least significant bit can be seen there on top of the image if you open in Steganography. Now there is maybe I will look at the pixels once again, but if this tag didn't catch it, it's unlikely that it's here. Because what this is using the tool by luckcolors is extracting every and single pixel of the image. And it is extracting in X. So basically we have 0F, FF, FF. So, and FF is white, and this is a minimal change, so the least significant bit. And so I don't believe it's in the pixel because this tag would catch it. So maybe we shouldn't have CDMT. Damn it. MT CDC CD2. Okay, I shouldn't have. So maybe what we need is to have a new idea, because if it isn't on the headers, if it isn't on the least significant bit, there is only one place where you can hide more data, and that is, I mean, without using encryption obviously, and that is in the filter algorithm. Basically the filters are digits or bytes that are in the beginning or end of every row, because pixels are aligned by rows, and at the end of each row you have a filter type that basically is used to optimize the compression of the raw data into a PNG itself. So you can change these filter types to hide a message using binary, base 2, so base 2 binary, base 3, base 4, or base 5. And so for this, I would have never been able to solve it without the help of Instanact himself, and he provided me with a tool that is open source, and it's this one, libpng.python, and I will load it. So Python 3, then import libpng, and then I can't remember, but I have the code right here saved. So you always have to import libpng, and then and then you should use this code to make it easier, because you will replace all of this huge command by only image. And shit. Okay, done. Now check this. If we type image.ihdr, I'm confused. What happened? PNG from file should have worked. Okay, I'm back. I made it work. It basically wasn't allowing it because Python was on the main directory. So now let's go image.ihdr, and as you can see, it gives you right away the width, the height, the bit depth, and the color type that is specified on the IHDR. Then if you specify image.pixels, you'll get all the pixels in X, but it's slightly different output than it is from luckcolors. I prefer the output from the luckcolors tool. And so what we need is the image width times the image bytes per pixel, that is 3 RGB, that we have 3 pixels times the width, and then we want the last pixel, because that's where the filter type is, right? So let's run this code that basically will tell the software to extract all the filter types that are between 0 and 1. There you go. So grab this and you go here to 50, and you need to do some boring work, so maybe let's use Notepad. Replace with nothing, and then we have this, replace with nothing, this, replace with nothing, and then let me see if I can get this right. Dot 8, and you replace it with h1. Nope. Rejects. Done. Okay, perfect. And then you go here and you get the last flag, and done. And it's done. And we have the 7 flags. 1, 2, 3, 4, 5, 6, 7. I hope you liked this tutorial. We basically went through every single way of adding data in the second way, so real steganography. That is not encryption and it's not visual. The visual steg, usually it's really easy, you just need to use Steganography or just Photoshop or GIMP and get it. Regarding encryption, you will need the exact software to get the data out. But regarding real steganography, we have seen everything. So thank you, goodbye. Thank you for watching, everyone.